Hello, everyone, and welcome to this special webinar on Southern Plains climate and drought conditions. My name is Joel Lisenby. I am the Regional Drought Information Coordinator for the Southern Plains Drought Early Warning System at the National Integrated Drought Information System, or NIDIS. If you'd like to learn a little more about NIDIS, head on over to drought.gov. We've got a lot of data and other maps and information. You can even sign up for email alerts for when drought conditions change at your zip code. I also sit at the Cooperative Institute for Research in the Environmental Sciences at the University of Colorado in Boulder. Before we jump into the webinar, I would like to acknowledge and thank a handful of people who helped organize this. There's too many for me to read, but you know who you are, and thank you for your help putting all of this together. First, allow me to cover some of housekeeping items on this webinar. Everyone is muted, and the webinar is being recorded. The webinar recording will be available on NIDIS's YouTube channel and also linked from the webinars page at drought.gov/webinars. I also plan to send around an email later this week when the webinar summary is posted. We'll have time after both presentations for a question or two. To ask a question, please use the question box, which is located in the GoToWebinar control panel, and indicate your name and affiliation. I'm really looking forward to today's presentations. We're going to start with a talk from Victor Murphy. Victor is the Climate Services Program Manager for the National Weather Service's Southern Region, which encompasses the states of Oklahoma, Texas, Arkansas, and Louisiana, among other southern states. In this capacity, he oversees the various climate products and services that the National Weather Service field offices provide to partners for their decision support in their respective county warning areas or hydrologic service area. Immediately following Victor's talk, we'll hear from Jonna Infanti. Jonna is a meteorologist at NOAA's Climate Prediction Center. She focuses on subseasonal to seasonal outlooks, as well as participating in decision support services and serving in the Key Messages group. So with that, I will pass over to you, Victor. As soon as you're ready, go ahead.
Thank you, Joel. Okay, you can see where I am there. As Joel mentioned, I'm the Climate Service Program Manager for Weather Service Southern Region Headquarters. We're based in Fort Worth, Texas. Next slide, Joel. So I'm going to be covering the states of pretty much Texas, Kansas, Oklahoma, and Texas here as far as drought goes. We'll start off with the big picture, then we'll end up drilling down to a smaller picture. So on the left, I have pretty much where we were at this time last year as far as the drought monitor goes. On the right is the most recent drought monitor. You can see there's not a whole lot of change across Kansas or Oklahoma, but Texas was the worst off of the three states back in last year at this time. And you can see it's still far and away the worst at this time this year also. In fact, drought conditions across Texas have actually worsened a little bit over the past year, especially across parts of central and south central Texas and west Texas. Next slide. So let's start off with Kansas. Let's go ahead and drill down here. There you go. So you can see the so looking at Kansas here, they had February 2024 on the left compared to February most recent drought monitor on the right. You can see pretty much the same thing. Not a whole lot of change. There were a few patches of severe drought back in 24. There are none this year. Perhaps of interest would be the DSCI, or Drought Severity Coverage Index, on the far right there, that graph. You see it was 80. That's basically a score ranging from 0. If there's absolutely 0 areas of drought or moderate dryness in a state, that would be 0. At the maximum, it would be 500. So you can see the score last year, this time was 81, 88 this year. So not a whole lot of change across Kansas. Actually, things were still looking pretty good as they did last year. Next slide. Okay, so this here is a graph which shows the drought levels across Kansas for week 6 of the calendar year, which is about where we're at right now. And it's based on some studies by Greg Ibendahl of Kansas State University. And it goes back, you can see we start at 2003, we come through 2005. And the score is pretty much based on how much of the state is in D1 or worse. So you can see right now, basically the score for this year is 0, with only 23% of the state being in D1. And I've got some highlights there, or arrows, which show other years that were very similar to this year. 24 was similar. Um, Let me see here, as was 2016, 2017, and 19 and 20. So I would expect going forward that any kind of the winter wheat crop, which of course is a big thing this time of year in Kansas, conditions should be pretty good for that going forward. You can see how bad things were in 2013. 100% of the state was pretty much in D1 or worse. Same thing in 2023. Definitely not one of the better years. That score was 69%. So this year, no severe drought, just relatively smallish amounts of abnormal dryness to moderate drought. So conditions should be very good, at least at this point in time, going forward for the winter wheat crop. Next slide, Joel, please. Okay, for Oklahoma, pretty much same thing as Kansas, not a whole lot of change. My ovals got misplaced there as I switched over from PowerPoint to Google. I apologize for that. I want to highlight the DSCI here, same thing, the Drought Severity Coverage Index for Oklahoma. You can see in 2024, it was 20, this year 74, still relatively low number. You can see a lot of states have normally dry, just a few patches of D1 or moderate drought. You can see basically 7.5% of the state right now is in drought. Last year it was only 3%. So Oklahoma, again, similar to last year, is also about the same condition. Next slide. But being springtime and being Oklahoma, being the Southern Plains, things can change quickly. There has been some pretty significant dryness across a lot of western Oklahoma over the past 30 to 60 days. You can see over half of Oklahoma, about the entire western half of Oklahoma has had less than 50% of normal precipitation over the past 30 days. So things are sort of trending in the wrong direction or bad direction for Oklahoma. Next slide, Joel. And so speaking of which, as good as things looked last year for Oklahoma, I think the DSCI score is only 20. All it takes is, one significant event with the right conditions or wrong conditions. You can have, major fires, wildfires developing. So as dry as relatively wet as Oklahoma was last year, we saw just about zero drought in northwest Oklahoma or the Panhandle. There was 150,000 acres that were burned last year in northwest Oklahoma on one week. And of course, that was the week of February 26th. We're coming up to that 1 year anniversary of that. Nearly $9 million in damages. You can see the largest fire was in Ellis County, had 90,000 acres burned up there in northwest part of the state. And so, as good as things are looking right now for Oklahoma, the wildfire danger is just, right around the corner, and it's always possible if you get the right conditions. So at the very bottom of the slide here, I have the conditions for Gage, Oklahoma, which is in northwest Oklahoma. On that given day from February 26th, you can see at 2 o'clock in the afternoon, they had sustained winds 34 miles an hour, gusts of 53, air temperature of 84 degrees, dew point temp of 29, humidity is only 14%. So very, very hot conditions, very dry conditions, really strong winds. Doesn't take a whole lot to get wildfires burning, and I'm sure the forestry officials in Oklahoma are keenly aware of that. So it seems like if you get the right conditions or the extremely volatile short-term day in day out conditions, that can override whatever the big picture climate background might be as far as being wet or dry. Next slide. And so one of the reasons for concern, you can see here that this is the drought. This is the seasonal drought outlook that's developed by the Climate Prediction Center, which John is going to, where John works at. But you can see the forecast is for drought development across pretty much all of West Texas and the western half of Oklahoma between now and the end of May. So just further credence, and also notice western Kansas too. So just further credence that, as good as things are right now from a drought perspective, very little drought ongoing right now. Things are forecast to take a turn for the worse in that regard. Next slide. And same thing here. This slide here is from Oklahoma Mesonet, wonderful entity. And once again, this shows a number of consecutive days with less than a quarter inch of rainfall by calendar day. You can see just about the entire western half of Oklahoma got at least 60 days without a quarter inch of rainfall. But most of the western third of the state, 96 days. Today's 97. Nothing on tap for the next week or so. So we're going to be running at about 100 plus days. By the first week of March, we'll be running 100 plus days with less than a quarter inch of rainfall on a calendar day across that part of Oklahoma. So you can see where things are headed, unfortunately. Next slide. Okay, for Texas, slightly different theme. The state was already the worst off of the three this time last year, and this year is definitely much worse off. You can see in the D3, D4 area there, 17% of the state is in D3 or D4, which is extreme to exceptional drought. You can see the drought severity coverage index is 167 this year, which is double what it was last year. As you can see, there's just been two main persistent areas of drought. One in far west Texas, which has gotten bigger or worse in the past year. And the other one has been in the hill country of Texas to the west of just the west of Austin, San Antonio area in the I-35 corridor. And that has also stayed in place. It's actually expanded southward and southwestward towards the Rio Grande over the past year. Next slide. And so Texas, same situation as Oklahoma. You can see the 30-day rainfall, precipitation. A lot of the state there around the Lubbock area, I-40 area southward towards I-10. That right now is just in abnormally dry conditions. You see the amount of precip they've had in the last 30 days, basically less than 10%. Less than 10%, less than 25%. So unfortunately, we're probably going to see some increase in moderate drought in this area the next week or two in the drought monitor. So that will only worsen things or expand the drought footprint across Texas. You can also see how dry it's been in South Texas, also from San Antonio southward. So a lot of that area is already in extreme drought D3. It looks like that the size of the drought footprint will likely expand southward towards Rio Grande in that area. So actually 2 to 3 different areas of concern for Texas. Southeast Texas in good shape. North Central Texas, DFW area, good shape. So Houston, DFW area is no problems. Next slide. Okay, getting back to the February 26th, you can see they did have the last year we had the once again, despite relatively benign conditions, the worst of the fires, the wildfires from that February 26th event or week, was actually the Smokehouse Creek fire just east of Amarillo there. And you can see it burned over 1 million acres. It's the largest wildfire in the continental U.S. since 1910, which is over a century. And you can see the conditions there for Amarillo. Same thing as we saw from Gage earlier. West winds 32 to 62, wind temperature 81, dew point 28, 14% humidity. So very strong winds, abnormally strong winds, high temps, high humidity. Despite any absence of drought or maybe lack of drought, if you get these types of extreme conditions, fires can still flare up, especially if it's a case of maybe a down power line or something like that. Next slide. So the biggest issue for Texas, I think, going forward is going to be, water supply in a lot of these reservoirs. So you can see a sort of a tale of two states, if you will. All the reservoirs east of I-35 pretty much are highlighted in blue there, is because we have 80% to 90% of capacity right now in the reservoir. Those in yellow or those in orange or red are less than about 50%. You can see there's a big striation there or bifurcation with reservoirs in the eastern part of the state doing really well, those in the south part and western part not so well. Next slide. So here's the statewide water supply. You can see we're at 76% capacity statewide, which is not bad. I mean, it's a little bit higher, a little bit better than we were in 23 and 24. Still about 10% less than the statewide average for this time of year. The statewide average is at dashed line there should be about 83%. We're at 76. And once again, you can see even though the average is 76, it's a lot higher than that east of 35, a lot lower than that west of I-35. So next slide, Joel. A couple of areas of specific concern, and these are the areas that we were looking at earlier with long-term drought. Looking here at some river basins, the Nueces River Basin is one of definite concern. You can see there right now it's only 18% of the capacity. That comprises two different reservoirs, Choke Canyon and Lake Corpus Christi. The latter is used for water supply for the city of Corpus Christi. You can see the two reservoirs combined are at 18% of storage, far and away the lowest they have ever been for any time of year, much less this time of year. You can see the graph there on the bottom left. That diamond is where we're at this year compared to last year. The other dashed line there, just beneath the blue rectangles, is the previous lowest for this time of year. And the Corpus Christi area right now is under stage 3 water restrictions. Once again, South Texas, and the headwaters of these, the rivers that feed this, the Nueces River, they're in that drought, in that persistent drought area to the west of San Antonio and southwest of San Antonio. Next slide. The Rio Grande, not much.
Victor, you've got about 1 more minute.
Thanks, Joel. Rio Grande right now actually is at 22% capacity, tracking at all-time lows. It's been tracking at all-time low for about 18 months now. So it's definitely going to have impacts on the lower Rio Grande Valley. Next slide. Okay, Lake Travis, the west of Austin, running about 43% of capacity, about half of where it should be at this time of year. Good news is it's a little bit higher than last year. Bad news is, once again, still only half of where it should be for this time of year. Next slide. So in summary, Oklahoma and Kansas are at near normal drought levels for this time of year. Nothing too alarming, but of course, March and April bear watching for wildfires. Texas problematic. Many reservoirs in South and West Texas are near or much below normal. Springtime rains, which should be coming in April, May, June, will be huge to see where we're at for going into the summer. And quite honestly, water managers in Texas will really be under the gun, especially in those drought favored areas there, as far as making decisions and managing the water supply. And of course, also from a policy perspective, the Texas legislature is meeting this year, and I believe there are a lot of different water policy measures on the table for review or discussion, and rightly so. And that's all I have, Joel. Thank you.
Great. Thank you, Victor. We'll just pass right over to Jonna for the talk about our seasonal outlooks. Jonna, as soon as you, we can see your slides, so go ahead.
Great. Thank you very much. Thanks, Joel, and thanks so much for everyone for listening today and for inviting me to speak. My name is Jonna Infanti. I am one of the forecasters at the Climate Prediction Center. Today, I'll be discussing seasonal outlooks and how to interpret them. So to begin, CPC has a number of outlooks that support the long lead forecast timescale. So what we consider that is the monthly outlook and the updated monthly outlook. Those come out twice a month. The seasonal outlook, which comes out once a month, as well as the monthly and seasonal drought outlooks that come out as well. I know these images are quite small, but you can find all of this on our website. So if you want to take a closer look at any of these, please feel free to visit. And you can find these outlooks by going to the CPC homepage. I've highlighted here some of the more pertinent information for this forecast timescale. So the U.S. drought outlooks, the 1 month outlooks and the 3 month outlooks are things that you might be interested in taking a look at. One thing that I want to note is if you were to take a look at where the 3 month outlook is noted, there are actually two options. One is just to show, for example, the seasonal temperature outlook and the seasonal precipitation, or the monthly temperature and precipitation outlooks in a PNG or an image sense, so you can see the probabilities there. But there's also this interactive option where you can click into any place on the map or search for an address or zip code, and it will give you an approximation of the probability for above, near, or below normal precipitation or temperature for that given location, as well as the normal maximum and minimum temperatures and normal precipitation for that region. So that's a really cool thing that one can take a look at if you do want to see something that's more specific to a given region rather than looking at the national maps. And then for this particular talk, I'm going to be mainly focusing on the 3-month outlooks, but obviously feel free to click around our website. If you want to go directly to the pages, I have them listed here. You can also find them from the homepage. If you have any questions on any of the other outlooks, particularly on the long lead timescale, I'd be happy to try and answer those questions, or I can find an answer and send you to the best person to answer those questions. So for the seasonal outlooks, which is what I'll be mainly focusing on today, they're comprised of 13 outlooks of rolling seasonal means, and these are released on the 3rd Thursday of each month. So you can see an example here of the seasonal temperature outlooks and the seasonal precipitation outlooks out for 1 year. These were the ones that were just released on February 20th. So for example, for the outlooks that were released on February 20th, that would span March, April, May 2025 through March, April, May 2026. We have rolling 3-month seasonal means in between there. And what these outlooks show are tercile probabilities of seasonal mean temperatures and seasonal total precipitation amounts for the given season. And they are accompanied by what we call a prognostic map discussion, or PMD, which will tell you more about why some of the decisions were made for these particular forecasts, why some of the probabilities might be increased or decreased, and things like that, as well as telling you some of the drivers behind the particular forecast. So this is a very general slide for understanding CPC products. If you need a reference to go back to, this is a great reference. This point example is actually from our 8 to 14 day timescale, but this works very similarly for the seasonal timescale as well. And this is more geared towards probabilistic temperature outlooks, but this is a really great overview. So I felt that it was good to show this. So any of these maps that show tercile probabilities are showing shading that indicates the probability of temperatures or precipitation being in the most favored of any one of 3 categories. And those 3 categories are above normal, near normal, or below normal. So any of the shading on these maps is indicative of probabilities ranging from 33 to 40% to 90 to 100%. And any gray shading that one might see on the map is indicative of near normal temperatures being favored or most likely. So what does above or below normal mean? And that is above or below normal relative to the 30-year climate normal for that given region and period. So for example, in a seasonal timescale, we have the March, April, May prediction that just came out. Normal is relative to all of the March, April, Mays from 1991 to 2020 in a mean sense. And our forecast would be showing if we feel that there's higher probabilities for that upcoming season to be above, near, or below normal. One thing that's really important to note is that though the entire season is what's shown on the map, individual days may vary. You can get variations in the season, but we are predicting that the mean of the entire season will be above, near, and below normal. So if you take a look at this point example here, this would indicate that there's a 61% chance that the average temperatures in a given period will be above normal. So I will show some examples from this particular outlook for March, April, May. As I said, I'm not really going to be focusing on the drought outlook, more on the seasonal temperature and precipitation outlooks, but I did want to bring this up, this image up here just because I won't have a specific point that I want to bring up. But in a very general sense for the seasonal temperature outlook, what you're seeing is this blue shading, which is chances of below normal temperatures from the northwest into the northern Great Plains. And then this red shading indicates chances of above normal temperatures over the southern tier of the US and up the East Coast. Then for precipitation, we have green shading, which indicates above normal precipitation chances over the northwest and over the Great Lakes into parts of the northern Gulf states, as well as below normal chances of precipitation, or chances of below normal precipitation over much of the southwest and parts of the plains as well. And what you can see here, and Victor was bringing this up and gave a very, very nice overview, is the US drought outlook for this upcoming period. And this is valid for February 20th through May 31st. You can see that this corresponds to some of the below normal that you're seeing in the seasonal precipitation outlook over parts of Texas, where you can see that drought persist or drought development likely. So how to read these? The darker shading on either the temperature or the precipitation maps indicates higher probabilities. So just for example, this light green shading is a 33 to 40% chance of precipitation falling in the upper tercile for that season. And if you have darker colors, that goes up in probability categories. So with this very dark shading here, this is 50 to 60% chance of precipitation falling in the lower tercile. Or relatively darker shading, comparatively speaking to the other categories. You'll also see white areas on the map. That indicates equal chances of above, near, and below normal precipitation. And that's indicated where tools have high disagreement or a category is not favored. You may also see, although it's not included on this particular outlook, gray shading, which I was noting earlier in these slides, indicates chances of near normal precipitation or temperatures. So again, the outlook show the probability that the seasonal total precipitation amount will be below, near, or above normal. And we can have individual days or periods within this season that can vary, but overall, that's what we're forecasting for the season. Temperature obviously works very similarly. Lighter colors are lower probabilities, darker colors are higher probabilities, and these are the probabilities that the seasonal mean temperature will be below, near, or above normal for a given season. So one might ask, how do we come up with the probabilities? Why would we determine if an area or region has higher or lower probabilities? And the reason is because we use a variety of tools. And I have an example of some of the tools that we have here. I know this is a bit small, and I'm not planning on going through each one of these in any great detail, but just to give you an example, a visual example of something that we might look at. We look at dynamical climate models, typically multi-model ensembles, such as the North American Multi-Model Ensemble and the Copernicus Climate Suite. We also take a look at tools that estimate or show the influence of trends, the state of the El Nino Southern Oscillation, local impacts like soil moisture or snow cover when they're relevant to the forecast, and climatologies. So as I said, this is an example of some of the tools that we may look at. There's a number of tools here, and I'm not going to go into each one individually, but one of the areas that I do want to point out is you can see a lot of brown on these maps and in these tools, right in that region that lines up with where we have higher probabilities of below normal precipitation on our maps. So a forecaster might increase probabilities where there's strong agreement or consistency among tools. If there's known regions of strong ENSO impacts in a given season, higher probabilities in some tools, areas where we know there's typically high skill, or due to input from regional experts. We might decrease probabilities where models show weak or inconsistent signals, low skill, weak teleconnections, or due to input from regional experts. If anyone does want to know more about the reasoning for any of these given outlooks and the probabilities, we do, as I was saying earlier, include a prognostic map discussion. So that will give you an explanation for why we might be seeing some enhanced or decreased probabilities, or some regions where we might see below normal or above normal precipitation or temperatures. In terms of what is normal, I already did explain this a bit, but just to give you another visual here. Normal is defined as for any particular location and season. We define 3 categories from 30 observations from 1991 to 2020. The coldest or driest 1/3 of the years defines the below normal category or the B category. The warmest or wettest define the A category or the above normal category, and then the remaining 10 in the middle define the normal category. So again, I know these pictures are fairly small, but we do have this on our website, links to images for each one of the seasons that we forecast for. That will show the mean temperature, the median precipitation, lower tercile and upper tercile temperature and precipitation as well. So you can take a look at these maps, and that'll give you an indication of what we mean by above, near, or below normal. Another way to do that, and I covered this in some of the earlier slides, but just to reiterate, is to take a look at our interactive outlooks. Again, one can put in an address or a place, or you can click directly on the map. That will give you an estimation of what the probability is for a given region, as well as telling you the normal maximum, minimum temperatures, and normal precipitation for that point on the map. So that's a little bit of an easy way to be able to take a look at some of these regions and see what we're looking at in terms of probabilities and normals. So to summarize, you can visit cpc.ncep.noaa.gov to find a variety of outlooks. We don't just do these long lead outlooks, we also do 6 to 10 day, 8 to 14 day, and week 2 US hazards outlooks. The seasonal outlooks that I was showing show the probability that the seasonal mean temperature or total precipitation amounts will fall into the above, near, or below normal category. And that normal is based on the average of the given season from 1991 to 2020. Very important to note, individual days and periods will still vary within the season. And another important note is because we can have those individual days and periods that can vary, there could be some periods of extremes within a season, but the seasonal outlooks themselves do not indicate any chances of extremes. They're indicating tercile probabilities. And thank you very much for your time, and I'm happy to take any questions. You're more than welcome to email me after the fact if you think of something later, or chat me. My email address is listed here, and thanks again.
Great. Thank you so much, Jonna. We've got just about 2 or 3 minutes left, about 2.5 minutes left. There was one question about, is there a place where people can go and find the near normal range for any location? And is near normal, is that range for near normal, is that set? Like, the question is like plus or minus 2 degrees for temperature, same question for precip, or
Yeah.
is there more statistics behind how that normal range is defined?
Yeah, so the near normal, so I have this slide here. This is a pretty basic way of putting it, but so we define the driest as the driest third, the warmest, or driest and wettest, or driest and coldest as the lowest third of the years, the warmest or wettest as the upper third of the years, and then near normal would be the middle area of that calculation. So it's all based on 3 tercile categories. So terciles, you're looking at everything in thirds.
And are those tercile thresholds available anywhere?
I mean, this is the upper tercile. This is these
okay.
thresholds are on the maps here.
Right. Okay.
Yeah.
Thanks. And there are a couple more images, or a couple more questions that are starting to come through. Does the CPC do any smoothing on the normals for shorter term outlooks?
For shorter term outlooks, that's a good question. Most of our observational data would be around 1 degree. By 1 degree, we might have half degree. So we don't necessarily do any additional smoothing on the normals, but we do potentially have coarser data than one might be looking at WFO level.
Okay. Thanks for that, Jonna. That takes us to the end of our time, so I'm going to wrap us up there. And thank you for those of you that have submitted questions. I'd also like to thank all of you for attending and making time to learn more about the climate and drought conditions and the outlooks. I would like to again thank our speakers, Victor Murphy and Jonna Infanti from the National Weather Service and Climate Prediction Center. And that concludes today's webinar. I thank you all again for attending, and I hope you all have a great day.